Hi students. In the previous session, we have seen what is numerical integration, and some basics about the Gaussian quadrature, its applications, and where do we use this numerical integration. Now, in this session, we will solve some of the examples on this numerical integration. As we already said, this Gaussian one-point formula will have integral f of x dx, that is equal to 2 into f of x, that is c1 into f of x1. So that's what we have seen in the previous classes. So this is what the general formula to find the integral value under one point Gaussian quadrature, and this is regarding the 2-point Gaussian formula. So where this integral f of x dx is equal to this c1 into f of x1 plus c2 into f of x2. Here this x1 and x2 takes the value minus 1 by root 3 and plus 1 by root 3, where this c1 and c2 takes the value 1. That is, the weights of the 2-point Gaussian quadrature would be 1. So that is why this 1 into f of x1. So simply we are writing f of x1 plus f of x2. And regarding this 3-point formula, we have to go for 3 weights and 3 discrete points are Gaussian points. So x1, x2, x3, and its corresponding weights w1, w2 and w3. See, this minus root of 3 by 5 and plus root of 3 by 5 will stand for x1 and x3, whereas this x2 becomes 0 and its corresponding weight becomes 8 by 9. And the weight of the weights of this x1 and x3, that is the w1 and c1 and c3 would be 5 by 5. Okay, so just by looking into this formula, we may get a little confusion. We will solve a problem so that you can clearly understand the concept. So let us evaluate integral minus 1 to 1 dx by 1 plus x square by 1 point, 2 point and 3 point Gaussian formula. So we will see one by one. So first we will consider a 1-point Gaussian quadrature. Here let us take the f of x, the integrand, as 1 by 1 plus x square. In 1-point Gaussian quadrature, as we already told, that this is equal to c1 into f of x1, where this weight c1 is 2 and the discrete point or the Gaussian point x1 is 0. So 2 into f of 0. So that means that in f of x, wherever we have x, there we have to substitute x is equal to 0. So that becomes 1 by 1 plus 0 square. So this becomes 2. So the integral value of this particular integral, that is minus 1 to 1 dx by 1 plus x square, will give you the value 2. So you can check it out by normal integration method also. Now by 2-point formula, see, minus 1 to 1 f of x dx is c1 into f of x1 plus c2 into f of x2, where c1 into c2 stands for 1, that is weightages. So those weight measures can be taken from those tables what I have shown in the previous classes. So now we have to see this minus 1 by root of 1 by 3 as the value minus 0.57735, and this 1 by root 3 becomes root of 1 by root 3 becomes 0.57735. So its value after substituting in this f of x, you will get 0.75 and 0.75. So finally the value becomes 1.50. So the integral value of this under 2-point Gaussian quadrature is 1.50, and this is under 3-point formula. So as I already told you, this is a c2 f of x2, this is c1 f of x1 plus c3 f of x3, and here this f of 0, f of minus what is it, f of x1 and f of x3. So all can be found out using the formula f of x is equal to 1 by 1 plus x square, expression 1 by 1 plus x square, and after calculating this you will get the value as 1.305. So you can observe here we have three different values. So depending upon the number of points we are considering, the quality would be improved. Thank you.